Welcome back to this tutorial in which we shall now build up on the introduction that we put in place last tutorial, and we shall now look at them practically. Let's bow down for a word of prayer. Father, Lord in heaven, we invite you in this session that we would understand whatever we're going to learn. You being the greatest mathematician, teach us this session. Just may pray. Amen. Now remember, we spoke about 4 common types of loci. I want us to now look at them practically and how they apply in our mathematical life in constructions. So basically, I'm going to look at this example of a question that contains all types of loci in one. So we shall be able to work on that. Construct triangle ABC in which AB is 9 centimeters, triangle ABC is 120 degrees and BC is 6.4 centimeters. So basically, number one, we construct the triangle. So I'll make us assume that we are constructing everything by the use of a ruler and a pair of compasses. So I have my tools. I believe you also have your tools ready. So we shall begin working by number one, drawing the sketch. We have been told that we have a length AB, A to B, which is 9 centimeters. This angle here is 120 degrees, and this length is 6.4 centimeters, and this is point C. So basically, notice that this angle here is 60. So we can use the protractor, but in this case, we have not been told which one to use and which one not to use. But because of practice, and many people usually fail to know that, we shall construct that particular angle so that you may understand it clearly. So quickly, we shall construct our triangle. So I begin by having a good line, and then I pick my pair of compasses, measure a distance of 9.4 centimeters. Pick any point, stand on any point on the line, draw an arc, then put my compass on the point that the arc I've drawn and draw an arc. This will give you A and B. And then at point B, we need to construct an angle of 60 degrees. So we'll basically pick any radius, stand on point B, construct a circle, but not a full one. It's not necessary. Just construct a circle like that. Then with the same radius, don't change it. Stand on the next point that you have drawn, then draw an arc. And then join, just join this. This angle here is 60 degrees, the remainder is 120 degrees. Now we were told up to point C, 6.4 centimeters. We measure 6.4, and always make one strike of an arc. We can join this now to A. That's point C, 6.4 centimeters, 9 centimeters. Pick a pair of divider. Some of us have never used a divider since it was ever bought in our geometrical sets. Measure the distance AC, which is our first question. And the divider is usually more accurate than measuring with the ruler. And then after measuring, just place it there. Left 13.7. So AC, which was our first question here, we are asked to measure and write down the length of AC. So AC is 13.7 centimeters. Notice here we have used the first locus of points in which point C is anchored to point B. So we need to draw point C with respect to point B. So that's a locus of points on which one point is fixed to another point. Next, we are told draw locus of points that are equidistant from points A and C. So points A and C, points A and point C, what does that mean? There's a locus in this line, between this line, that will be equidistant. That simply means we draw what? A perpendicular bisector. So we'll have our pair of compasses more than the center. You just have a radius that's larger than the center, draw an arc on the upper side and an arc on the lower side, the same radius maintained, cut that arc, and then the moment you join these 2 points, you will have a locus there. So this is a locus that is in between A and C, equidistant. If you measure these 2 lengths, you'll find that it's equidistant. I'm just giving you a rough sketch so that you may be able to draw it and prove it for yourself. Next, you've been told, draw locus of points that are equidistant from lines A, B, and B, C. Now this simply means we are drawing a locus that's between the 2 lines. Notice if it's in between 2 lines and these 2 lines are intersecting, we draw a locus that divides this particular angle. So basically, after having that, notice we have been asked the locus of lines AB and BC. What will that be? We will come here and then draw an arc around that angle, bisect it, draw an arc upwards and another arc down, like that. And then the next thing, you will also divide another angle. Now you'll notice that the steps we are taking for this question, drawing the locus of points between lines, it will simply be the formula that you use to draw an inscribed circle. Inscribed circle. So we have that. Then we join this here. So this is basically a locus of points, not basically this one, it's here. This one here, I believe you can notice it. Let me draw it in green. That one gives us the locus of points that is equidistant from BC and AC. So basically, if I just prove it here, you'll notice that I can draw a radius as inscribed circle that will touch those 2 points. So it touches those 2 points. So it's equidistant from those 2 places. Now, just because of my quick drawings, you find that it missed this point, but it should be an inscribed circle. You'll work on that. I'm just quite quickly following up this because of a timer that I'm having. So after having that, the next question you've been asked is draw the locus of points that are 4.2 centimeters from line BC and on the same side of BC as A. So it simply means I'm drawing a locus of points that's 4.2 centimeters from this line. So it means there's a locus from that line. That means it is another line that is away from line BC on the same side of A. I believe you can notice that. It's not anchored to BC. So we'll have a locus of points that will be a line perpendicular to BC. So we'll basically measure length of 4.2 centimeters, then drop a perpendicular. Can have the long method, drop a perpendicular from BC, drop a perpendicular that goes through C and goes through B, and then you join those points. But another very shorter method is by the use of a set square, whereby I can have this 2 points like this, and then I'll just slide it until whereby it will be a tangent with my arc, that point. And here I'll have drawn the locus of points 4.2 centimeters away from BC in the side of A. Then finally we were asked, draw a circle of radius 4.2 centimeters that touches the lines A, B, and BC and label center O. In this point, we are going to now have a locus of points that's equidistant from two lines, but now we have been told a specific radii. So how will we work about that? Notice we have already picked the length 4.2 centimeters from line BC. We'll also pick another length of 4.2 centimeters from AB, such that where these two lines will meet, it shall be the locus of points that is fixed or equidistant between these two lines. So we basically come here, measure 4.2 centimeters again, but I've not touched my compass. I'll have that arc like that. Pick my set square, and then slide it up to that point, not that point, up to the tangent. So basically, at the point whereby these two lines meet shall be the center of my circle here. And notice at this center is whereby we have the bisector of the angle. So basically, it's simply this particular point whereby it bisects that line. I believe you can now notice the point that we were explaining. If I have a point that is anchored at a specific point, it divides that particular point, that particular angle. And basically, if I draw my circle, you shall notice that it shall touch those sides. And then I'll label my center O. I believe you have seen what I've simply done. Just to zoom the question so that you may attempt it at your own room temperature and pressure, you can have that question. You can pause the video and get it. And may God bless you.